reduce that. Okay, so you're going to try and simplify to a single trigonometric ratio. What that means is that you need to have an answer either in terms of sine theta, cos theta, or tan theta. Okay, so try that, and then we can move on to the next question. Okay, so Mohammed, you've got an answer already. That's cool. Okay, so if you feel that you've done 5.11 successfully, you're welcome to try 5.1.2. I'm just writing down the question, so don't worry about what I'm doing. You guys just carry on. Okay, so can you see that you've sent me an answer? Cassandra, you've shared an answer. So some people are saying cos theta, some people are saying negative cos theta. Okay, so this is what I've done so far, all right? So sine 180 minus theta reduces to sine theta. Cos 90 minus theta reduces to sine theta as well, minus 1 over cos minus theta. So cos minus theta is positive cos theta because that's quadrant 4. So in the numerator, we've got sine theta times sine theta minus 1 over cos theta. So that's sine squared theta minus 1 over cos theta. So what we could do if we wanted to, we could factorize out the negative, or we could write sine squared theta minus, and remember 1 is sine squared theta plus cos squared theta, isn't it? So I could use my square identity there too, if I wanted to, over cos theta. All right, which is going to leave us with sine squared theta minus sine squared theta minus cos squared theta all over cos theta. Sine squared theta minus sine squared theta is 0. And negative cos squared theta over positive cos theta I quite agree with you, is negative cos theta. Okay, I didn't get 1. I got negative cos theta. Does that make sense, Matrix? That it would be negative cos theta. Are there any questions? Sure, go for it, Mohammed. What's your question?
Ma'am, is sine squared minus 1 not cos squared theta?
No. So you've got to be careful there. Okay, let me just show you this again. Mohammed, it's so easy to get this wrong, isn't it? Okay, so I'm going to write this on the side for you. Okay, so from grade 11, sine squared theta plus cos squared theta is 1. Okay, so if you want to make cos squared theta the subject of the formula, you would have to take this over to the other side, right? So that would leave us with 1 minus sine squared theta. So can you see sine squared theta minus 1 is not the same as 1 minus sine squared theta. Okay, so it's funny, I actually had a discussion today with one of my grade 12s about this, right? And the idea is this, is if you say 3 plus 3 minus 4, or if I say plus 4 minus 3, do we get the same answers? We don't, okay, because plus 3 minus 4 is negative 1, and plus 4 minus 3 is positive 1, so it's not the same thing. Okay, Mohammed?
Yes, ma'am.
Okay, so you would have to either factorize out the negative, or you'd have to use the identity. So your alternative here, Mohammed, would be to do this. So from this step here, you could also say, take out the negative, and then write this as 1 minus sine squared theta over cos theta.
Okay, then you have minus sine squared.
And that would give you
cos
minus
squared.
cos squared theta over cos theta, blah, 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 blah. Yeah.
Okay.
Okay. All right, no problem. Matrix, how do you feel? Does that make sense? Everybody happy? Thumbs up, thumbs down, smiley face. Yes. Cool. Nice. Okay, so now that we have reduced that, lovely guys, thank you. So now that we've reduced that successfully to a single trigonometric ratio, in other words, minus cos theta, the next thing that they want us to answer is they say hence determine the values of theta for which this will be real. Okay, so hence determine the values for which this will be real. Okay, so hence means using our previous answer. All right, so now in order for something to be real inside a square root, what is the restriction? Because remember, we've worked out what that is. So now minus cos theta. All right, so remember, so now we want this to be real. So that means that what's inside here, yes, exactly, it cannot be a negative number. Quite right, it can't be negative, it needs to be positive. Good, guys. So whatever is inside our square root, the value of that, I'm just calling it y, has to be greater than or equal to 0. Right, so whatever is inside our root, our negative cos theta, has to be greater than or equal to 0. So what I could do if I wanted to here is I could divide both sides by -1. So that would be, where is cos theta smaller than or equal to 0. Remember, I've got to turn my inequality sign around when I divide by a negative. This is one way for me to look at it. Okay, so for which values between 0 and 360 is cos theta negative? Okay, so now I'm thinking about my graph. Let me just get rid of this. Okay, so my cos theta graph matrix, what does it look like? Okay, so if you recall, it looks something like that. Okay, so here this is 0, there that's 90, that's 270, no, hang on, 180, beg your pardon, that's 270, and then back to there would be 360. So it's going to be negative, all right, between 90 and 270. Okay, so that is when theta will be real. Okay, so between 90 and 70. Is there anywhere else, Kat, where it would be real? So between 90 and 270 is where cos nowhere else, hey?
That's what I got, since
Okay.
theta is between 0 and 360. So that's the only answer.
Okay.
Sorry, ma'am. Can I just find out?
Yes. Yeah, Cornelia, go for it.
With this question specifically,
Yes.
can you just write the answer itself, or do you have to like basically write cos theta is less than 0?
I think that this would be answer only.
Thank you,
This
ma'am.
would be answer only. So in other words, like everything that I'm writing here, I'm just kind of, this is me sort of explaining to you what it means. And then this is me sort of explaining to you a little bit further what it means. And then this is also me sort of explaining to you over here what it means. So yes, I think in this situation over here, it would be your answer only. That would be your 2 marks. Okay. All right, no problem. Yes, so you're quite right, Esel Bavuma. The square root of 0 is also real as well. So in other words, or could it be at 0 degrees? That's what I was thinking, Kat. Or where theta is equal to 0 degrees. Because the square root, if it's 0, because
Isn't it 0 on the x-axis, not the y?
So it would also be where cos theta is equal to 0, which would be, no, but you see then it wouldn't be there, would it?
Yeah.
Yeah. Yeah, exactly. Cos 90, exactly. So that's why we've included the 90 and included the 270 because it's equal to 0 at both of those points. Okay, now I'm satisfied that we've done that correctly. Okay, so yeah, no, Michelle, you don't need to calculate anything. It's just understanding what's inside the root and then answering it based on that question. Okay, which is what all these things in the blue circles ended up being, is just me explaining to you what it was that they were trying to get at. Okay, so yeah, a bit of a thinking question, that one, wasn't it? All right, let's move on and let's have a look at, again, this is going to be a little bit of a challenging question. Right, in fact, both of these are a little bit challenging. So determine with the aid of a diagram and without the use of a calculator, the value of cos alpha if sine 2 alpha is equal to root 15 over 8, and 2 alpha is an angle between 0 and 90. What makes this question difficult, Matrix? What makes this challenging, in your opinion? Absolutely. So in other words, we've been given sine 2 alpha. We're working in terms of 2 alpha, but we've been asked a question about cos alpha. Okay, do you see that? Okay, so here, the reason why this question is difficult is because here we've got sine 2 alpha. Here we're talking about 2 alpha, but yet here what they want from us is cos alpha, not cos 2 alpha. All right, so what do you think we should do? What do you think the first thing is we need to do? Because they have given us a hint here. They've said determine with the aid of a diagram and without the use of a calculator.
Ma'am, can't we do Pythagoras?
We can do Pythagoras. Cornelia, I want to ask you a question. In which quadrant are we working?
The first quadrant.
Absolutely. Why? Exactly, Cornelia. Well done. Because it says there that 2 alpha is an angle between 0 and 90. Lovely. Well done, Cornelia. That was 100% perfect. Okay, so we can do the theorem of Pythagoras. All right, so I'm going to let you guys do the theorem of Pythagoras. I'm going to let you interpret sine 2 alpha and do the theorem of Pythagoras, and then we'll talk about the next steps after that. So as soon as you've done Pythagoras, you can share your answer with us. What did you get doing Pythagoras? Okay, so there's a couple of different answers. Some people are getting 7, some people are getting 8. Orachile, you got 78. I think that was just a typing mistake. Okay, so someone said R is equal to 7 to Nico. Okay, so remember guys, if we are given sine, let's do this in a different color. Okay, so if we are given sine 2 alpha is root 15 over 8. Remember, we interpret sine alpha or sine 2 alpha, sine of any angle, as y over r. Okay, so that means it's the x coordinate that's missing. So we would say x squared plus y squared equals r squared. Okay, because of the theorem of Pythagoras. So this would give us x squared plus 15 equals 64. So that means that x squared would be equal to 64 minus 15, which would leave us with 49, sorry. Silly me. This is why I love you so much, Kat. All right, and now x would be equal to plus minus the square root of 49, but we're in quadrant number 1, so quite right. X is 7, not R, okay, but X is 7. Okay, so what that means is we can now write cos 2 alpha okay, would be 7/8. Does that make sense to everybody? There we go. Lovely. Okay. And it's nice, Mighty. I love what you did there. Okay. I think that's a really good idea. It's what I encourage my matrics to do at school. So I get them to make a summary. All right. So I get them to write, okay, so y is √15, x is 7, r is 8. Now we're ready to answer any questions that come along.
Lee,
Yeah.
wasn't it for cos A, not 2A? Alpha, 2 alpha, sorry.
Yeah, that's what I'm saying. That's what I'm saying. This is now the problem, okay? Because what they're asking us for is now cos alpha, all right, not cos 2 alpha. So we haven't answered the question. This is not us answering the question, right? So now we've got to try and find a connection between what we've done and cos A. Does anybody know what the connection is? How are we going to go from sine 2A or cos 2A or tan 2A to A? How do we do that? Anyone got any ideas? Kanisile, yes, you're quite right, using a double angle. So what have we got to do here? So I'm just going to give you a little hint. So cos 2 alpha, okay, there's 3 things that it could equal, right? So either it's cos squared alpha minus sine squared alpha, or it's 2 cos squared alpha minus 1, or it's 1 minus 2 sine squared alpha. What could we use? Cornelia, I'd use the middle one. Yeah, Tisha, even me. Exactly. That's the one that I would use because we want cos alpha on its own, don't we? So I would do this. Okay, quite right. So everybody, cos 2 alpha is 2 cos squared alpha minus 1. From up here, you know what cos 2 alpha is. Okay, it's 7/8. So what we're going to do here is so clever. All right, we're going to sub in our 7/8 equals 2 cos squared alpha minus 1. And now, isn't it amazing, Cornele? I knew you'd get it. You're a clever guy. All right, so now what we want to do is we want to solve for cos alpha. So I'm going to take the 1 over to the other side. So now I've got 7/8 plus 1 equals 2 cos squared alpha. So that would leave us with 15/8, wouldn't it? And now we want to divide both sides by 2. So now we've got 15/8 divided by 2, which is going to leave us with, again, with tip and times. So I get 15/16.
Mm-hmm.
And that's equal to cos squared alpha. And now we've got to take the square root on both sides. Sorry, I really don't give myself enough room to write everything. Okay, so now we're going to take the square root. Okay, but again, remember we were working in quadrant number 1. So we're not going to worry about positive, negative. So cos alpha, I suppose we could do that and then just say, so that's going to be √15/4. Okay. That's it. Does that make sense to everyone? Yes. Oh, cool. I'm so glad to hear that. Buhlobo. Yes, Buhle. Good. Oh, nice, Rachel. Yes, Tisha. I like the heart. Yes, ma'am. Thank you, Kanisile. Good, Michelle. Glad you guys are feeling good. Okay, it's nice to do a little bit of more challenging work, isn't it? Okay, so the next question that we've got lined up here is also a thinking question. Okay, is Elbow, please can you express that? Yes. So if you want to, sorry, and it kind of all sort of melting into one here, isn't it? So this fraction over here, if you wanted to, you could write this as 15 over 18 times 1 over 2 if you wanted. Or if you want to write it as 15 over 18 divided by 2. Okay, instead of writing it as a complex fraction. Okay, but that's basically what we're doing. Okay, nice. All right, well, let's carry on with the next question. So 5 marks for that. Without using a calculator, determine the value of cos 0 plus cos 1 plus cos 2 plus da 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 plus cos 178 plus cos 179 plus cos 180 plus 2. Now it's only out of 3 marks. Okay, so we see a question like this. There has to be some kind of trick to it, right? There has to be. So it's just a case of us looking at it very carefully, thinking about what we know and figuring out what the trick is. So I want you guys to think about it for a little bit. Or if you want to share your answers straight away, if you've got an idea, then that's also cool. Okay, but Mohammed, did you do that without the use of a calculator?
Ma'am, this question we had in our exam before.
Okay, so you've seen it before.
Yeah, they never knew what to do, so I'll figure it out now.
Okay, yeah, unfortunately, that's the thing. If you do enough maths papers, eventually you'll see it. There are a lot of questions just kind of get recycled and whatever the case is. So,
Because I only saw one of these questions in one of the papers that I did.
yes, yeah, you probably wouldn't see it too often.
So does this fall under problem solving?
Yes, it would do, because it's basically something that is unseen, that is a little bit different, and you've kind of got no idea where to start with this particular question. So yes, this would be considered problem solving. Not particularly difficult problem solving, but yeah,
So do you
man
get
has
3 marks for just saying the answers too?
No. You're not going to get because the thing is that if you write down the answer only, right, then they're going to assume you used your calculator. So you've got to show working. So in order to prove that you didn't use a calculator, you're going to have to show working.
Okay.
Yeah, so that, yeah, absolutely. Okay, so that's the whole idea here, Kulani. Okay, now I see now, look, Rachel's saying sum of a series. I can understand why you would think like that, Rachel. And can you see they also made that suggestion once? And you know what? The one year they asked a question like this and they gave it to you, gave you this question or similar question using sigma notation. So I'll actually see if I can find it and show you guys another time. But fortunately, this is not as difficult as this. All right. So what this hinges on you understanding is rewriting certain things in a different way. Okay. What I'm going to do is I'm just going to grab that. And sorry, this is just all the other stuff that I wanted us to do today. I'm just going to come down here and post it there so that we can have a look at this question. Okay, so this is what it hinges on. Right? You've always got to think to yourself with trig, how can I rewrite things in a different way so that I can manipulate them? So in other words, you've got cos of 0 plus cos of 1 plus cos of 2. Oh, sorry, I didn't write that very well. Hang on a second. Cos of 2. Oh, what happened to my purple pen? cos of 2 plus da 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 da. Right? Now, how can we rewrite cos of 178? I can rewrite this as the cos of 180 minus 2. Plus the cos of 179, I can write this as the cos of 180 minus 1. Plus the cos of 180, I'm sorry, now we're running out of space going sideways. It's always something, isn't there? So the cos of 180, if we think about our graph, that would be -1, isn't it? Plus our 2 at the end. So can you see here how clever this is? This is a pattern, all right? So cos 180 minus 2, see, so you're going to end up with cos 0 plus cos 1 plus cos 2 plus, what kind of plus is that? Ach, Jere, I get so irritated with myself. Honestly, why am I writing it as cos squared? Sorry, guys. Cos 2 plus duck, 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 duck. Okay, now cos 180 minus 2 is minus cos 2, isn't it? Okay, and cos 180 minus 1 is minus cos 1 plus cos of 180 is -1 plus 2. So can you see what's going to happen here? All right, so everything between here and here is going to add up to what? What's it going to add up to between the square brackets? It's all going to add up to? Ha ha! That's it. Well done. You can see it. Lovely. Well done. It's all adding up to 0. What is the cos of 1? Oh, sorry, the cos of 0. So again, think about your graph. The cos of 0 is 1, isn't it? Okay, I mean, I suppose we could do that on our calculator, but okay. So now we've got 1. All these zeros. So 1 plus -1 plus 2. And that's why Muhammad said the answer was 2. Okay, 1 minus 1 plus 2 is 2. We did. Yes, we used reduction here. We just used reduction. So we wrote cos 178 as the cos of 180 minus 2 so that we could write it as minus cos 2 so that it could cancel out to 0 with the plus cos 2. Clever, hey? It's a pleasure. Okay. So now, who said that they were okay, so Tisha, you felt like you were totally blank in the beginning. What do you think now?
No, genuinely, I was also not going to get this in the exam. I'm also blank.
Okay.
You explained it, yes, but it's still, yes.
Yeah, absolutely. But you see, Cornelia, again, it's one of those sorts of questions that you're not going to get the answer unless you think. So, because there's not just a formula that we can apply in this situation. We've got to really think about the things that we know and understand in order to be able to get to the answer. So, and the thing is that if you feel like you wouldn't have been able to do that in the exam, that's fine. That's one of the nice things about us being able to do maths together here is to expose you to this, so that if you do if your teachers do come up with something like this in the trials exam, at least you have been exposed to it as an example somewhere else. And hopefully it gets you thinking in that problem solving kind of way. Okay, can you see, have you got a question?
Yes, ma'am. Ma'am,
Sure,
why
go
do
for it.
teach us things like this during our lessons? Because it's my first time seeing such a question.
Really?
Yes, ma'am. Even in
Okay.
the speeches that I've done, I've not seen such a question. And I
Oh,
was
wow.
not gonna get it.
Okay, so yeah, you see, I suppose also it's difficult for the teachers to maybe go looking for these sorts of questions because they don't know where to find this sort of material. I know I'm quite lucky. I work at a school where we try and do a lot of problem solving with our students. So we specifically go and look for difficult questions to do with them, to expose them and get them thinking about things. But the best thing you can do, Kanyisile, is go and have a look at the department papers that are online as well, and you'll see in there are problem solving questions that you'll be able to do. And I will try and do as much of this as I can with you as well. Okay.
Thank you very much, ma'am.
It's a pleasure. It's a pleasure.
No. How come? How is the answer 2 though? Like the 2
Okay.
is there, but like you wouldn't have actually figured this out.
Yes, absolutely. No, I mean, unless you were thinking in that way, you wouldn't have been able to figure it out. Absolutely. Yeah, but I will. I'll try and find that question with the sigma notation in it that I'm talking about. I'm sure it's online somewhere. I'll find it for you guys and I'll show you next time. Yeah, and then we can have a look at how we would have answered that. Okay, so yeah, there's a little bit of problem solving for you. Okay, all right, shall we go back up and go and have a look? Okay, so can you see, I don't know if you remember, Shane, you asked me a while ago if we could do some trig functions, and I don't know if we ever got to it, but here you go. Here are your trig functions, okay, can you see there? We finally got there. All right, so here we go, guys. So we've been given the graph. Also, again, not easy, okay? And that's why I've chosen these questions on purpose to do with you, Michelle. In the diagram, the graphs of f of x equals tan 2x and g of x equals 1 plus sine 2x are drawn on the same system of axes for minus 135 to 135. Okay, first of all, if they say tan 2x, what's happened to our tan graph? What's it doing compared to our normal y equals tan x graph? How is the graph y equals tan 2x different? Ah, there we go, Boutle, 100% the period changed. Okay, so Boutle, how often does a tan x graph repeat itself normally? Exactly, Tisha. Okay, so normally a tan x function has a period of 180 degrees. But if it's now the graph of tan 2x, it now has a period of 90 degrees. Okay, so it's repeating itself every 90 degrees instead of every one. Exactly, Mr. Bavuma, no problem. All right. Yeah, so it's repeating, that's it, Carlos. It's repeating itself every 90 degrees instead of every 180 degrees. When we say g of x equals 1 plus sine 2x, same story. The sine graph is repeating itself more frequently. Sine graphs normally repeat themselves every 360. So if we've got a graph of y equals 1 plus sine 2x, what's happened here is it now has a period of 180 because it's repeating itself every one, and it has been shifted 1 unit up. Okay, so it's been shifted 1 unit up and it's also repeating itself more frequently. So that's what we're looking at. Again, both of these are fairly complex. They're not straightforward. The first thing that they want us to do in question 6.1 is to write down the equation of the asymptote of f in the interval minus 135 to 0. So the equations, because there's two of them, of the asymptotes in the interval from minus 135 to 0 is what do you think, Matrix? There are two of them. So they're vertical lines. The first one is minus 135. That's this line over here that I'm just drawing in purple now. Cool, can you see there? Which is the answer. The other one is where x was equal to negative 45. Well done. That's lovely. Good job. Here's the other one. Okay, Matrix. Right, so we would have to say both of those to get 1 mark. Okay, so that's question 6.1. Good. Question 6.2. Now, things start to get more difficult again. If h of x is sine x minus 2 sine cubed x over 2 sine squared x times cos x, determine h of x in terms of f of x. All right, so now there's a little bit of calculating that we need to do here, right? So we've been given an expression in 6.2 for h of x. All right, so don't panic, okay? Just think about the things that we know how to do. When you want to simplify an expression, all right, and we've got pluses and minuses, what do we normally do? We have to factorize. Okay, so if we've got pluses and minuses, we have to factorize. So can you see here, Matrix, we're going to factorize absolutely, Boucle. Let's factorize the numerator. What can we take out? Indeed, quite right. So we're going to take out sine x, and this is going to leave us with 1 minus 2 sine squared x, isn't it? All right, then if we've got 2 sine squared x cos x at the bottom, one of the sine x's at the top and one of the sine x's at the bottom can cancel out. So now we've got 1 minus 2 sine squared x, which is sine 2x, over
Isn't sine 2x at the bottom?
Yes, it's cos, sorry, I'm just being a numpty. Beg your pardon, guys. 1 minus 2 sine squared x is not sine 2x, is it? It is cos 2x. All right, I'm just being silly. Okay, so 1 minus 2 sine squared x, guys, is cos 2x. 2 sine x cos x is sine 2x. And cos 2x over sine 2x is 1 over tan 2x. So that would be 1 over f of x, because they asked us to write h of x in terms of f of x. Okay, does that make sense to everybody? Or have I sort of blown your brains at this point? How are we feeling? Is there steam coming out of our ears? Have we grown hair on our chests? Okay. Yes, can you see, Lee?
If we had to leave it at 1 over 10 to x, would we still get the mark, or we have to leave it at 1 over f of x?
I would say you'd have to leave it as 1 over f of x, can you see it? Because they did say that to us in the question, that we've got to write h of x in terms of f of x. So yes, I would say we would have to do that. Okay.
Yes, ma'am. So, ma'am, where would we actually get the marks for this sort of question?
Okay. I think there would have to be a mark for factorizing. Okay, so Shame, I think there's a lot of people who are feeling a bit sort of mind blown at this stage. I'm sorry, Matrix, I didn't mean to scare you or anything. I just wanted to do questions with you that would sort of try and challenge you a little bit, but I didn't want to challenge you to the point where you now wanted to start crying. Okay, so all we've done is we have simplified the expression, just like we would simplify any identity or trigonometric expression. So we've taken sine x out of the numerator, and we've been left with 1 minus 2 sine squared x, right? At the bottom, we've been able to cancel the sine x at the top with one of the sine x's at the bottom. So at the top, we've now got 1 minus 2 sine squared x. And at the bottom, we've got 2 sine x cos x. This is an identity. Okay, it's a cosine double angle identity. So it's cos 2x. This is also a double angle identity. It is sine 2x. Now, guys, sine x over cos x is tan x, isn't it? Whoopsie daisy. Is tan x. So is tan x. So if you put cos x at the top and sine x at the bottom, it becomes 1 over tan x. Okay, it's the reciprocal. Oh, Cornelia, I agree. If only we could carry on going until 8 o'clock. Hey, it would be so nice. Oh, there we go. Kat's just explained that to you. Okay. Thank you, Kitty Cat. You are so wonderful. Oh, okay. Does that make things a little bit more understandable now, Matrix? Okay. So it's the reciprocal.
Ma'am, what's the other reciprocals?
You fortunately don't need to know the other reciprocals in grade 12. So the other reciprocals are sec theta, cot theta, and cosec theta, but you don't need to worry about that, fortunately.
So we don't need to know those at all.
You don't need to worry about that at all. It's not part of CAPS. Okay. Yeah, thank goodness. There's more than enough difficult stuff with just what we've got. Yeah, so that is, you need to know all the tricks. Quite right, all the tricks of the trade, so to speak. Okay, all right, so that was that nasty one for 4 marks. Now again, like I said to you before, I'm not trying to scare you, but these are purposefully challenging questions. Let's have a look at 6.3, because I'd like to just finish the graph with you guys before we finish today. It says determine the values of x for which tan 2x times minus 1 minus sine 2x is smaller than or equal to 0 for x is an element of minus 135 to 0. Now again, what they are doing here is that they are bringing in our understanding. Yeah, that's quite right, Boucher. Trig, okay? They are bringing in our understanding of quadratic inequalities, okay? But it's not difficult, okay? So now, just bear with me a second for question 6.3, right? Let's just move this guy out the way because I don't think we're gonna get there this lesson, but we can always try that another time. Come on, go. Hey. Okay, there we go. All right, so remember in paper 1, you have a question like this. So for example, x squared plus 3x plus 2 is smaller than or equal to 0, and you have to solve for x. Okay, it's a quadratic inequality, isn't it? Right? So what it's saying to us is, well, for what values of x is y negative? Because x squared plus 3x plus 2 is f of x, it is y. Okay, so what do? We factorize it. We factorize it to get our critical values. So in one bracket, we would have x plus 2. In the other bracket, we would have x plus 1, wouldn't we? And we'd all come along and say, well, our critical values are going to be where x equals -1 or where x was equal to -2. Then we would draw our graph or a number line, And we would say -2 is over here and -1 is over there. And the values where y is negative is going to be between these two, isn't it? So we would say when x is a number that is greater than or equal to -2, but smaller than or equal to -1. Do we all remember these sorts of questions?
Yes, ma'am.
We all remember that. Okay, so now this is no different. We've got tan 2x. Okay, it's just got a twist. It's just got a trig twist. Okay, so this is tan 2x minus 1 minus sine 2x. And then what have they done? They've said smaller than or equal to 0. Okay, so they've just thrown an additional dirty in here. So can you see they've factorized it? Okay, they've given us a bracket. Now, what we want to do is we want to take the negative out of the second bracket, because remember our other graph is 1 plus sine 2x. So if we take out the negative from this second bracket, we've got negative times tan 2x times 1 plus sine 2x is smaller than or equal to 0. What happens when we divide by a negative with an inequality? The sign changes, exactly, the sign changes around. So if we divide by -1 on both sides, we've got tan 2x multiplied by 1 plus sine 2x is now greater than or equal to 0. Everybody happy with that so far? Switch the carrot thingy. What carrot thingy? The question. Okay, so now we're asking ourselves, okay, the only way we can interpret from this point onwards is we have, so tan 2x represents the outputs on the tan graph. 1 plus sine 2x represents the outputs on the sine graph. So really what they are saying to us here is f of x times, was it g of x? So this is really what the question is asking us, okay? For which values of x is f of x times g of x greater than or equal to 0? Often we see it like this. So f of x times g of x greater than or equal to 0. You know those sorts of questions. The sideways carrot. Yes, okay. Oh, that's funny. Right, so it's really this question over here. That's what they're asking us. Okay, so now we've got to go and have a look. There's two ways we can answer this. Either when they're both positive, because when a positive times a positive gives us a positive, or if they are both negative. So what we're doing is we're now looking, where are they either both above the x-axis or where are they both below the x-axis at the same time? Okay, so now we're going to go and have a look at our picture. Where are they above the x-axis at the same time or below the x-axis at the same time? Where is the x-axis? There it is. Okay, so the only place, because look, the graph of G is always above, isn't it? It never goes below. So we cannot consider any values of G that are negative. So it has to be where they are both positive. So where are they both positive? Can you see from here? From minus 90, they're both above. All right. To both above, both above. Okay, to here. Can you see that? They're both above. Okay, here between minus 45, the one is above, the other one is below. Then at 0 degrees, okay, can you see that they are both above again? Do you see that? At 0 degrees, they're both above again. But they've told us only between minus 135 and 0. So here, this is going to be between minus 90 and minus 45 or at 0. Does that make sense to everybody? Okay, so where it's going to be greater than or equal to negative 90. But smaller than 45, they're equal at 45. They're equal at 45. Or equal to 0, they're not, they're equal to one another. Or where x is equal to 0 degrees. Sorry, minus 45, sorry. Minus 45, it's minus 45.
Lee, why is it not equal to negative 45? Because the question said, where's the product either equal to 0?
Yeah, where's the product equal to 0?
And
Yeah, so we can include negative 45, can't we?
yes, at 45,
There's no
it's
reason.
0 times.
Yeah, at 45, the product is 0, isn't it?
Yeah.
Yeah, okay. I agree. Yeah, so we're going to include negative 45. Yes, so Michelle, it's happening. Sorry, let me just show you here. Between here and here, Michelle, so I'm going to highlight here. Okay, there. They are both above the x-axis at the same time. Okay, and then here at 0, they are both above the x-axis at the same time. All right, so it doesn't work. Yes, can you see it?
You can finish here. I wanted to ask about the inequality one that we did down there.
Sure, do you want me to go back down?
Yes, please, ma'am. Ma'am, what is the reason for the inequality sign changing?
It's because we divided by a negative on both sides. So in other words, sorry, can you see Lay? So what I did here, I took a negative out the bracket. So get this bracket that I'm coloring in blue, there's the negative that I took out.
Okay.
Okay. And then I divided by -1 on both sides, and that's why the sign changed from being smaller than or equal to greater than or equal to.
Oh, okay. So, ma'am, does that mean that every time when we divide, the inequality sign changes, or only when it's a negative number?
Yeah, absolutely. Can you see it? And the reason that it does that is because of this. All right. So the easiest way for me to explain it to you is like this. Okay. If I write here that 6 is smaller than 10, okay, I've written a true statement, haven't I? But now if I divide both of these numbers by -2, I'm saying -3 is smaller than -5. Now just think about that for a second. Is that true?
No.
No, it's not. Okay. And that's why when you divide by a negative, the sign has to change around. Okay.
No, I understand, ma'am. Thank you.
Okay. It's a pleasure. It's a pleasure. No problem.